nowadays is a professional engineer in both Canada and the U.S. And is also AP LEED certified. He graduated from the Ohio State University in civil engineering. He has over 30 years experience in the engineering field, as well as 10 years as a professor at Fanshawe College, working in the Donald J. Smith School of Building Technology. In his career, he has worked on high-rise construction, project management, and environmental engineering. While he's been here at Fanshawe, he has been helping with the campus sustainability improvements, which include the solar panels that were added to the H building, as well as the solar walls that were added to the residential buildings this year. He also lives this lifestyle. He has owned an off-the-grid property since 2000. He was trained by Al Gore through the Climate Reality Project and is now a climate reality leader. He is also known as the our own Fanshawe sustainability guru, Tom Davis.
Thank you everyone for coming out for this little talk. It's kind of an action-packed show, a lot of information, and it comes with a little bit of a viewer advisory warning too. Some of the information I have to share with you is a little bit disturbing, but I need to sort of connect some dots, sort of lay the case out in front of you. And then the sort of last bit of this presentation is really talking about some of the things that we're doing here today to save the planet. As Stephanie had mentioned, that's kind of my mojo. That's what I do here at the college that I teach, and I fix the planet. So I've got a group of students. We're doing the first ever net zero retrofit for residential structures here at Kestrel Court, and lots of other cool things like solar walls. But I don't want to talk too much about that. What I will do is, if anything of those projects or anything you see today is of interest to you, your program, your family at home, come and see me. I'm happy to have the conversation. I'm happy to come to your classes. My approach to saving the planet is as a team sport. We have 200 programs here at Fanshawe College, some 40,000 full and part-time students, and there's a role for each and every one of you to play. And I'll help hook you up if you can't find it, okay? So, Climate Reality Project is, it was sort of brainchild of Al Gore. The whole idea was to spread the message. So in 2009, he had prepared a video called An Inconvenient Truth. And this slideshow presentation has spun off of that. So between 2009 and today, in the last decade, we've trained some 25,000 climate reality leaders around the planet. By the way, the training is free, and you're all welcome and invited to join training events when they come to a city near you in the future. And the show starts with this slide. This slide was taken in December 24th, 1968, and it was from Apollo 8 mission, which wasn't landing on the moon, but was there to scout future landing positions. So as the orbiter came around the moon and saw the planet, this photograph was snapped, and it's entitled Earthrise. This is the first photograph that we have of our home that was taken from somewhere other than Earth. Fast forward and look at our planet. I always jokingly tell my students that we have a highly technical name for our atmosphere. You see that thin blue line up there? We call it the thin blue line. And that thickness of the atmosphere is equivalent to, if I had a classroom globe in my hands, would be the thickness of the varnish on that globe. So it's a very ephemeral structure, and it's held here the same way we are, by gravity. And some 90% of all the oxygen is within the first few thousand feet of that atmosphere. A little bit of climate change 101. We have inbound electromagnetic radiation from our star, the sun. Some frequencies are known as visible light. Others are X-rays. Others could be gamma rays, radio waves. The visible spectra is what is most predominant on the surface of our Earth because of the atmosphere. So when we think of inbound energy from our star and the classic understanding of greenhouse gas, in science, when something heats up, it seeks equilibrium with the universe around itself and cools. So as our planet heats up, it would naturally eject that energy through infrared radiation back to the void of space. And so we've always had some of that energy re-reflected because we've always had some CO2 in our atmosphere. What's changing is the rate at which we're adding CO2 to the atmosphere. We're currently dumping 110 million tons a day into that thin blue line, and that is, in essence, the problem. So as we add that carbon to that thin space, we thicken the atmosphere, and more energy gets redirected back to our planet as opposed to leaving our planet at the speed of light. Sorry, I'm snapping a little too quickly here. The question would be, well, where are these sources of carbon? The short answer is everything we do is a source of carbon. When we plot that out, you'll see a sort of a pathological increase in our dependency and use of these fossil fuels over the past century. The reality is, we've had carbon before on our planet, back when we were dinosaurs. But yes, humans have been on the planet some 200,000 years. We're now experiencing the highest planetary carbon dioxide concentrations that we've experienced in 66 million years. And the cause is human. Some wonder if there's a correlation between temperature and CO2 concentration. So we have some 800,000 years of planetary data on those two data points. There are our CO2 concentrations below. You'll see the temperature scribed directly below those. You'll see as CO2 goes up, so does temperature. The kicker is off kind of to the right side of the scale on today. When you look at recent history, we've always oscillated on our planet between 180 and 280 parts per million. Today, we're some 415 parts per million, and on a pretty steep growth curve there. So, 40 years from now, when we need to be completely off of carbon in order to bring our planet back from the abyss, if we continue business as usual, what does that say up there? I don't even have a number, I can't read it there. My eyes are too bad. 600 parts per million. We start to have adverse human effects, respiratory distress, watery eyes, right around 1,000 parts per million. And I can guarantee you, CO2 concentration in this room now is over 1,000 parts per million. And by the time I'm finished talking, it will even be higher because we're all emitting CO2 as well. So you might wonder how much that heat is equivalent to, and it's pretty hard to understand these great big numbers. So 110 million tons of carbon equals the thermal output of 500,000 Hiroshima-class bombs. And even that is kind of mind-blowing to get your head around, so I'll help you a little bit. Here's one. So just imagine 500,000 of those right here. Global surface temperatures over the recent past. What we see is right around 1980, the blue lines represent cooler than average years. We haven't had a cooler than average year probably in most of your lifetimes. I usually ask my students who's been alive in 1980. Not many. Who here is around in 1980? I was an old fart man, right? So, and that's part of the problem. It's hard to recognize climate change when you're right in the middle of it. A comedian once said that the surest way to tell that climate change is real is that the hottest year that's ever been experienced is the one you're currently experiencing. And that's what we're doing. So, getting back to the hottest years ever, and ever is a long time, and in engineering we don't like to use ever and always and never. They're pretty sweeping statements, but when 18 out of 19 of the hottest years ever are the last 4 years, we see a problem. The Arctic is melting. 1 degree temperature change at the equator can be as much as 10 degrees temperature change at the poles. So the poles are heating up much more rapidly than any other place on Earth. You can see the first time we've ever had 90-degree temperatures in Alaska. Paris, again, I'm going to quickly take you around the world and show you heat records just over the past few months because I had to fit it all into an hour. This is what we call infrastructure damage, shortages of water, because everything needs more water when it's hotter. Even the other creatures that share this planet with us. Kuwait City, Saudi Arabia. By the way, I should tell you I don't read slides to people, so I'm going to flash these up. And you don't really have to take copious notes. Again, I can provide these slides to you, or we can have discussions afterwards. So don't, the important thing is just kind of hear the message and work your way through it. So last May in Japan, January, which is summertime in Australia. The reality is that we've had 225 locations on Earth that had all-time heat records last year. Highly unusual. Hottest ever period in the U.S. Here, closer to home, last year 90 people died in Quebec. And usually fatalities aren't that high in this part of the world. And the reason is we have a technology that's not working that well in here today, but air conditioning. Europe was built well before air conditioning was invented, so many portions of Europe don't have those technologies to take advantage of. Another infrastructure problem, when we put down asphalt, we call it hot mix asphalt. It's applied at 300 degrees Fahrenheit as a liquid. Well, when it gets heated back up, it becomes a liquid again. We're going to take a look at what I call the white roof of our planet. And saving the planet can be as simple as a paintbrush. If I had a paintbrush and a big bucket of white paint, and I painted every roof on the planet white, it would be equivalent to shutting down 700 coal-fired plants. We could do that tomorrow, or the day after we put our paintbrush down. That introduces an engineering term. It sounds kind of funny, but it's called albedo. Albedo is the reflectivity of the planet. The more reflective our planet is, the more of that energy reflects off of it like a mirror and goes back into the space at the speed of light. So the white roof of our planet is ideally white. The problem is it's no longer white. And I also worry about Santa's fate. I have children here, so. And you might wonder, why are we getting these extreme hots at the poles, and maybe like tomorrow we're going to get kind of cool weather here when it's 30 degrees outside today. Well, that has to do with the jet stream and a phenomenon we call polar vortices. To make a long story short, the less temperature difference between the poles, the more meandering the jet stream is. It bends and snaps. And you'll see a normal jet stream here. And then we'll show you one that snaps and pumps all that tropical air right up over the North Pole. That's what we call a polar vortex. And when that's happening in February, the North Pole goes above freezing, and it gets really cold in warm, traditionally warm places on Earth. So here's another example. In January of last year, you may recall, it got quite cold here, but it was also a record high temperature at the North Pole. Here you can see cooler than average temperatures, warmer than average temperatures around our planet. During one of the polar vortices, Chicago, Michigan, when we look at that Arctic sea ice, the North Pole is basically sea-based ice. The South Pole is land-based ice. We'll talk about that difference in a minute. But sea-based ice in the Arctic is in precipitous decline. In fact, we see a bit of a trend developing. So it's important to separate weather from climate. Climate is the long-term trends that we're observing due to the weather. Greenland is a place that's covered with a lot of snow that is land-based, and when it melts, it actually contributes to sea level rise around the entire planet. If half of Greenland melts or half of Antarctica melts, sea levels rise by 20 feet globally. I'm not sure how you melt half of a continent on one end of the planet and don't do it on the other. But let's take a look at Greenland. Recently, we were up there filming. Those clouds are basically the dust as the glaciers are exploding and falling to bits. Can't make this stuff up. It's disturbing, I warn you, okay? Stay with us, the good news is coming. I tell my students that we have everything we need today to solve this planetary crisis. And in fact, I could go to Home Depot and buy it all today. We don't have to invent anything. We just have to get started. Let's take a look at the oceans. We have 70% of our Earth is covered in oceans. Unfortunately, 97% of that water is of no use to humans. It's salt water. 3% of the water on Earth is fresh water. Of that 3%, 20% is in the Great Lakes. Aren't we lucky? Water is also something we refer to as a thermal mass, and think of it as something that's painted black, getting sunlight shined on it. Instead of being white, it's the wrong color. In fact, when we look back at Earth from space, if we want to identify where water is, we look in the infrared spectra. Why? Because all of the infrared is absorbed by water. It's a great way to store energy. Well, the problem is 93% of it is all in the oceans now. So here there's a bit of a lag from the air temperatures in the 80s, but the oceans didn't take long to catch up with the trend that we saw in the atmosphere. Heat wave days in oceans, something we never historically experienced to the degree we're experiencing now. And when we look at that buildup in the oceans, this goes down, this color here is some 2,000 meters, 2 kilometers below the surface of the Earth, where some, let's call it 10% higher temperatures than we had just a decade ago. Half occurred this century. We look at our bodies of water and we look at ocean surface temperatures here. We can see ocean surface temperatures that are what? 4 degrees C, warmer than average. What could possibly go wrong? Well, that energy, we can't destroy energy, we can't create energy, but energy sure as heck can be converted from one form to another. That's the first law of thermodynamics. Well, we have energy storage. Heat causes this air to rise. Hot air can hold more moisture than cool air. What could possibly go wrong? We start looking at these phenomena that we call hurricanes, typhoons, and cyclones around the planet. We're seeing the storms, the likes of which this planet has not seen in recent history. So we want to understand why hurricanes are doing what they're doing. So we've got hotter oceans. That's the fuel source. That's the fuel in the tank for these storms. The speed at which these kick up, before we watch these storms and they'd evolve over a matter of days or weeks. Now we can go from a Cat 1 to a Cat 5 hurricane in 12 hours. We don't have that prep time. Warm air holds more moisture, so we're going to have a lot more moisture. In fact, when I was a student 30 years ago, there was 5% less atmospheric moisture in our entire planet than there is today. The reason is temperature. Storm surges on top of these high seas that are caused by melting ice cause coastal lands everywhere on the planet to be submerged. And finally, back to that jet stream and the contributing factors of the swinging of the pendulum, let's call it, for our planet. So Hurricane Harvey, as Stephanie indicated during the introductions, I'm a civil engineer. That means we wear these funny little rings. And the reason we wear these rings is to remind us not to kill anyone today. So I haven't killed anybody today. And whenever I sign or seal a document, it's to remind us of our sort of responsibility for human health and life. So what I'll tell you as a civil engineer is that civil, let's dissect that. Civil is like civilization. And engineer is ingenuity, so we use our ingenuity to build civilization. We're nation builders. And the nations that we have built have been built on a premise that a 1 in 100 year storm was the worst storm that you would see in a lifetime because very few of us live more than 100 years. So looking backwards, statistically, that's the case. Now, what's changed? Everything. Now we're seeing 1 in 25,000 year storm events. There is no city on Earth that's engineered for that level of precipitation. No place. Other areas we're having storms that we haven't seen in 500,000 years. No storm pipe's big enough for that. Texas had 5 feet of water fall on. That's equivalent to 509 days of Niagara Falls flowing. Imagine that showing up in downtown London. What I just said, right? Everybody thinks, oh, it's pure rainwater, right? We can use that fresh water. Not really. It's got every other polyglot awful that it's come in contact with on the way down and once it hits the Earth's surface. Port Arthur, oil spills, that's where most of the gas in this part of the world comes from. Well, there were others during that same storm. So now storms aren't just storms anymore. They're cataclysmic and they have huge, long-lasting environmental repercussions. Well, now this is what I start to refer to my students as a statement of the obvious. We kind of let the genie out of the bottle. We've gotten a taste of what's going on. So just in the past year, here's Hurricane Florence about ready to hit North Carolina. Michael making landfall in Florida. Maria pummeling Puerto Rico. You know, I have to just talk about the social sciences here because in climate, we call this a social injustice, right? Who's suffering the most here? It's not the oil and gas companies, it's the people that have the least that are suffering the most. That is a social injustice. Some 3,000 deaths as a result of that one storm. Again, the rate at which it kicked up from a Cat 1 to a Cat 5, 18 hours. No time to prepare. Sandy hit the East Coast, and in fact, when Al Gore did his video in 2009, he projected that a Cat 5 hurricane would hit either New York City or Washington. Where he was wrong was he thought that that would spur the Americans into action. Well, in fact, Superstorm Sandy hit the East Coast, and by the way, in my lifetime, that's the first time I've ever heard a storm referred to as a super anything. Now everything's a superstorm. So here's Manhattan as a result of that storm. So when we look at this risk going forward, when it occurred in the 1800s, it would have been a 1 in 500 year event. Now we would expect to see one every couple decades. And 2030, there's significance to the year 2030. 2030, we should be 50% off of coal in order to save our planet. And if we don't do that, 2030 is the year that we need 2 planets to absorb all the carbon that we release into one. And every time I check, there's still only 1 planet. And with my students, I say, we all have grown up and maybe had a chance to drive the family car. I say 2030 is when we hand the keys to this planet to you. It's your planet. It's not a Tesla. It's kind of a beater right now. We got to fix it. So that leads to the notion of infrastructure damage. Again, the people that are bringing this coal and carbon to the marketplace aren't suffering the cost. And economics, we call that an externality. Somebody else pays the bill. The rest of us are stuck with the bill. Mozambique, Zimbabwe. Again, last March. I didn't have to go too far. I had to get this down to only 300 slides. I have 6 seconds a slide for you. So we know that everything has changed for all time, and we're in the middle of it. That brings us to the hydrologic cycle. I threw this in here, I kept this in here. There are meteorological students here. All right, and so this will hopefully tie into you. So what we think of is water in all 3 forms, solid, liquid, gas. What you're seeing here is the atmospheric moisture. We call those rivers of water vapor that move around the planet. The simple fact of physics I shared with you earlier, that hot air holds more water. And then the specifics of that is for each additional degree we heat our planet up, we can put 7% more water in the atmosphere. Hurricane Harvey was hitting Texas. We asked NASA to measure the water density. It was 70 kilograms per cubic meter at 5,000 meters. Can you imagine something 70 kilograms dropping 5 kilometers and landing on your head or your city? We have a new term. We call them rain bombs. Here's an atmospheric river dumping water in California. California, let's talk about that a little bit. So hot air holds more water. So where does that water come from? Well, it evaporates off of oceans, but it also evaporates off of land, and it gives us longer and more prolonged droughts. So floods and droughts are caused by the exact same thing. Hotter planet? Yes. So ironically, California has been getting pummeled by forest fires, and then you have a rain bomb hit it. The mountain ends up in the valley, and we call those landslides. So everything changes. We're driving this moisture off of thousands of square kilometers of surface, putting it up into the atmosphere through cyclonic action, putting it in a funnel and dumping it on some poor unsuspecting community. This is a rain bomb hitting Phoenix. Here's one rolling into Tucson. Watch it splash off the city. And by the way, those are very arid places on Earth. Highly unusual. Trend, perhaps, globally. Any insurance people in here? Wow. Business? Everything changes. Resiliency? So now we get the floods, and I can give you a quick tour. We did the temperature tours, regional Russia, Japan, North America, Michigan, cricket. I don't know how they survive in England like that. India, typically arid portions of the earth too. Breadbasket, right? Pennsylvania. You don't have to go far. All of these costs that you see are costs of carbon. Tulsa, this May, Iowa, just a few weeks ago. Last spring, Nebraska, again, think of the food source for the planet. When our bread baskets of the planet go underwater, they burn up, there are food shortages. Imagine that. 17,000-year storms, and what? How long? Not long. Remember, our cities are built for 100-year storms. 1,000-year storm, we don't stand a chance. Indonesia this past May, Germany, China, Paraguay, Iran, right? Desert region. Sao Paulo, which recently experienced droughts and now it's flooding. Pakistan, Argentina. Worldwide, when we look at these catastrophes, guess what? They're getting more intense and more frequent everywhere. When Al came to Canada in 2015 and we did a training event in Toronto, it was the first year Canada had ever experienced $1 billion in storm losses. We've never been below $1 billion since. The irony of this isn't lost on me. This enterprising person is now in a lawsuit with their insurance company litigating him for $1 million in damages to his art. I thought I was prepared. So we're going to look at this. So we're driving that moisture off of oceans and they're way hotter, but we're also baking it off of the Earth's surface at the same time. And because the atmosphere is hotter, it can hang on to it, and that old adage of what goes up must come down. That's what I say connecting dots. Now all of a sudden we're starting to make sense out of what's going on here. Well, these historic water reservoirs of fresh water, remember 3% of the water on Earth is fresh water. When we look for fresh water and we find this, we have major societal issues. Here's a lake in India, in good times, and this year. Again, social injustice. Women, children, poor are disproportionately punished. Rich people, they just turn the tap. That's easy, right? Think of that the next time you turn the tap. Australia. $28 billion, that's a little bit more than I have in my savings account. Cape Town was very nearly the first city on earth to run out of fresh water recently in 2018. Their observation after that was we can't depend on rain for water anymore. Zimbabwe, more social injustice, more in Kenya, more in Somalia. By the way, we need to help these people. The life expectancy of Sub-Saharan Africans is quite low. We find that when life expectancy increases, birth rate drops off. So planetary population will stabilize in 2050 at 9.5 billion people if we stop killing babies in Africa. Iran, I just showed you that underwater. Well, the entire country is basically in drought too at the same time. We see cracks in the dirt around here, nothing like that. This is business as usual, and watch the Great Lakes. I call it the Great River Erie, right when you guys get the keys to the planet. I'll be dead. I wonder if there's a correlation between temperature and fire. Yeah, sure enough. So Europe, Korea, Colorado, 105 days longer of a fire season, 365 days in a year. That means California is now in year-round fire season, yes. Speak of the devil, paradise, right? 14,000 homes vaporized.
The window is so hot I can't even touch the window right now. Oh, this is horrible.
Lakeport, Reading. That's what we call infrastructure damage. So when we look at the most expensive fires ever, they all happened in the last 2 years. Don thinks they can rake the forest and solve this problem. I don't think that'll do the job. Temperature and lightning strikes, guess what? There's a correlation. As the planet heats up, lightning strikes become more prevalent, and the more we have lightning strikes on dry Earth, the more forest fires we have. The Paradise Fire was actually caused by a hydro line in Delaware. Caused the largest utility on Earth, Pacific Gas and Electric, to declare bankruptcy as a result of one fire. Sweden, the white roof of our planet, right? When the roof is on fire, we have a problem. Greenland, those glaciers I showed you exploding just a few minutes ago, is on fire. Heard of the blood red full moon? This is taking it to a whole other level. Here in BC, similar things. Infrastructure, it's vaporized. Other end of the planet, Australia, you guessed it, same story, different locations. 2016, and this is the oldest slide I'll show you, there were these forest fires burning in Russia. As a result of that, 55,000 people ceased to exist, and World Food Price Index spiked. Why? Because all the farmland was burned up. What about mass migrations? We had 250,000 people leave North Africa and try to migrate into Europe. One of their sort of immigration camps caught on fire in Greece 2 days ago. Not going so well. What happens when we have 1 billion people on the move? And you have the keys to the planet. Number of extremely hot days, doubling. A third of the world's population, so 2 billion of us. End of the century, if it's your planet, year round. From 15% to 75% of the population with dangerous temperature. Very disturbing. What do you do with a billion people on Earth? You can't send it back home. Their homes don't exist anymore. Well, guess what? It started. This is from Build the Wall Done, right? I wonder why all these people are moving north. What could possibly be driving people to leave their home country? Well, a drought will do that. Honduras and Nicaragua, number 1 and number 4 on Earth for places to get out of. Food security, another social injustice. U.S. Department of Defense goes, hey, there's no way people can withstand this. So I'm going to very quickly take you through some of the intricacies and interconnections of the food chain. And some of those bubbles are up there. And then you see all these interconnecting lines. My students, I have time to go through all those today. I just show you that and move on. Right. What about water? Well, I'll spend a couple minutes on water since I'm 70% water by mass, so are you. So water's pretty important to us. Well, who uses all the water on the planet? Good question. Farming? Well, when this is your planet, we don't have enough farmland to grow the food to feed to the stuff we eat, let alone the water to grow it. Well, everything needs more water when it gets hotter. 40%. Yeah, I'm no mathematician, but let's call it 4 or 5 billion people. And again, increases in water demand globally. Even the poor camels have a hard time finding water. When we extract water faster than it's being replaced, groundwater, we call that mining. So we've been mining water for the past century in order to grow corn in the Midwest. Once the mine gets empty, the aquifers are depleted, they're no longer of any use to us. Here's a glacier that used to exist in Nepal. You can see sort of the bathtub ring around there. 1/4 of the world's population is fed fresh water from these melting glaciers. Doubling in 20 years. La Paz, Bolivia, same thing. They get their drinking water from glaciers that are disappearing from nearby mountains. Tree cover loss, let's take a look around the planet. Brazil, we know that's a problem down there. 20% of the carbon in the atmosphere this year was caused by burning the rainforest. Oftentimes we burn the rainforest to make room to grow food, or food for food. Also, palm oil has a very bad rap for knocking down rainforests in order to get, oil for cooking. The answer, quite frankly, is to go back to the old school. I tell my students, there's a sports quote that I've kind of bastardized, and it goes like this, and if anybody follows the Cubs, they had kind of a bad, and after 100 years, they finally won the World Series, and the quote goes something like that. The Cubs weren't really a bad team, they just had a bad century. And I go, well, humans aren't really a bad team either. We just had a bad century. We kind of drove this planet into the ditch over the last 100 years. So I look back more than 100 years for inspiration on how we fix it. And the number one way that we do it is we revert to organic agriculture. By not putting chemical herbicides and pesticides and fungicides on our soil is healthier. It stores more carbon, not for days or weeks, but for centuries. And high carbon soil makes plants more drought tolerant. And if we do organic agriculture everywhere where we're farming today, by the time this century is over, we're going to be going around hiring people to start burning trees and coal. So farmland around the world, organically grown, is on the uptick. Happy to report. Could be better here in North America, absolutely. Now we're making this connection that this planetary crisis is also a human health crisis. Number one health threat. Call for action. Okay, you wonder how does that affect my health? Well, guess what? There are a lot of dots to connect. But suffice to say, again, it's the weak, the infirm, the poor, the elderly that have the least that suffer the most. Encephalitis in children, killing 120 children. More deaths than any other cause. Heat, and all this stuff about gun control. What about carbon control? This is the most disturbing slide I've seen in my life, and I've seen a lot of disturbing slides. You're telling me 9 million people cease to exist every year because they what? Breathe air? Yeah. That's what leads us to another social injustice that we call death by power plant. Who lives downwind from these industrial facilities, the rich people or the poor people? The poor people. And the most vulnerable of those poor being children. Type 2 diabetes, high blood pressure in children. African Americans 3 times more likely to derive serious illnesses than Caucasians. Asthma, 2 times to 10 times the death rate. Great place for some athletic activity, right? Let's put some known human carcinogens into your lung as fast as we can. That looks healthy. I would suggest to you that that is not a wealthy school district. So back to death by power plant. This is actually a steel mill in Salt Lake City. Hospital admissions for children. You can see there bronchitis and asthma. The plant was shut down for retooling. At the same time, we saw a precipitous drop in hospitalizations. Then the plant modifications were finished and it was reopened, and hospitalizations went right back to where they were. Death by power plant. Now we look at pneumonia and pleurisy. Again, same scenario in Salt Lake City, before, during, and after. Particulate matter, especially PM 2.5, that means particles that are less than 2.5 microns. A human hair is about 100 microns. That stuff kills us. And the reason it kills us is our immune system has no defense because those particles didn't exist 100 years ago. They're man-made, and they're made by partial completion or incomplete combustion of hydrocarbons. Cost of mortality, percentages of GDP around the world. I apologize, Al's American. We kind of end up with some American highlights here and there. Bangkok, unhealthy air. Thailand, unhealthy air. By the way, this next slide is really disturbing, but these masks, what do they do in the way of stopping particles that are 2.5 microns in size? It's a trick question. They don't do anything. Yeah, I heard it over there. Nothing. Absolutely zero. Poland, well, a child now is like 1,000 cigarette a year habit, just being alive in your first year of life. Could you imagine? My entire lifetime, the planet's been trying to get rid of cigarette smoking. Now all you have to do is breathe air. India. Beijing, and a good day and a not so good day. Children again suffering asthma, bronchitis. For the first time in recent human history, life expectancy has been growing unless you live in North China. It's been retracting. So Shanghai Academy of Science, and by the way, the former Beijing mayor say Beijing is no longer a livable city. That whole adage of what goes up must come down, when we burn stuff that comes out of the Earth's crust, we burn other stuff that comes out of the Earth's crust. Heavy metals, arsenic, mercury, lead, zinc, And when those are attached to coal and we light them on fire and we let them blow across the country as these little tiny particles, we breathe them in, they go directly into our bloodstream. Women of childbearing age are told to limit their intake of fish. And by the way, you eat Lake Erie fish, that applies. 40% of the mercury comes from smokestacks. Tropical diseases, and let this thing populate for you. The last and more fearsome one is Zika. For the first time in the continental U.S. and South Florida, doctors are advising women to not have children for 2 years until they figure this one out. The result is, if a child is born with Zika virus, it is born with a shrunken head. It's a permanent issue. Tick-borne diseases on the uptick, 10 times over. Lyme disease, half the counties in the U.S. It's marching across Canada as well. Waterborne species, all that beautiful rainwater that falls down. Cholera is what? The Black Death, right? Dysentery, E. coli killed a bunch of people in Walkerton 20 years ago. When we have these flood events, all of these organisms get spread around and cause human health issues. Cholera statement. Brain-eating bacteria or amoebas, you heard that one yet? Oops. Great Lakes. 20% of the world's fresh water. What could possibly go wrong? Oh. Blue-green algae. What it has is a defense system, and that's kind of why penicillin was kind of cool that Fleming figured that out. The defense system that these algae use kill us. And there's no way to remove it from the water we drink. And this little city of Toledo, Ohio, had no water for about 3 weeks as a result of that. Ocean acidification. So CO2 in the atmosphere, about a third of the atmospheric CO2 gets absorbed by the oceans. You go, hey, that's cool. We thought that was awesome until we realized how much it's changing the ocean pH, and we have ocean reefs that are dissolving as a result and dying because of the temperature. Sea turtles' sex is determined by temperature. Now, 99% of them being born are female. It's pretty hard to propagate a species when 99% is female. Ocean invertebrates, down by half during a period, by the way, in which they were a protected species. We're expecting to lose half of all land-based animals this century. We're in the 6th major extinction event. The last time we experienced one, we lost 18 out of 20 species 250 million years ago when we lost the dinosaurs. Well, the poles are getting warmer and the tropics are getting hotter and drier. Guess where everything's going? Everyone's moving to Canada. There's our sea ice disappearing before your eyes. Just to kind of speed this up. Here it is in real time. The oldest and thickest ice that used to never melt, guess what? It's melting. Twice last year. When I see these pictures, I ask my students to imagine if they go home and unplug their deep freeze and come back and visit it in a couple weeks. It's going to be very malodorous, and the odor is caused by bacteria that are aerobic, and they eat the organic material and they fart methane. That's what's happening. We're unplugging the deep freeze on our planet. All the organic stuff that's been frozen up there longer than humans have been on the planet is defrosting, melting, and decomposing. That uncontrolled release of the methane that those microbes are farting, the methane is 25 times more of a greenhouse gas than CO2. So we used to be able to store carbon in the Arctic, and now the Arctic is a source of carbon, like the burning Amazonia. Again, I think of those photons falling from our star. One hits something white and bounces back. Something hits a water body or something dark and it stays here, and the heat stays here. Glacial activity going the wrong direction. In fact, in Greenland, let's look at all of the glaciers in Greenland. this century, so a whole 20 years, Kangerlussuaq is where I showed the glaciers exploding, melting 4 times faster. Guess what? We have a white roof on the bottom of our planet too, Antarctica. This is the rate of velocity of the ice sheets on that continent. Rapid increases in the rate at which this is melting. Just a few days ago, they discovered a big cavernous void below one of these glaciers. It's the size of Manhattan. We didn't know it melted that much. Warmest year on record. Again, our records go back 800,000 years for Antarctica, so we can say that with some confidence. This is the Manhattan thing.
Ice sheets rest on the ocean floor and can melt from both above and below sea level.
Double
Warm
whammy.
waters that are near those ice sheets. And if those warm waters actually touch marine ice sheets melt, and you have big changes in.
So sea level rise, and we look at population around the world. We have cities in India and China that are adversely affected. When we look at monetary value of real estate going underwater, well, Miami's #1. Also, China and India are well represented there as well. This is Al Gore. We did a training event for Climate Reality in Miami during a flood, and we knew when it was going to flood because this was high tide. So now, remember that phrase of supermoon? When we have a supermoon, the tide draws the seawaters above the street level in Miami Beach every single time. Norfolk, Virginia, Washington, D.C., fishing on the West Mall there. Nice little carpish action there. The beltway, they say, around Washington that used. Irony here isn't lost on me. The White House getting flooded. At least somebody's paying the price of insurance. $129 billion of real estate at risk in Manhattan alone. 12 million people moving in the U.S. alone. Of those billion, Parabolic is an island nation in the Pacific. They've actually had to buy land on continental locations to relocate their entire nation. Bangladesh, low-lying area, suffering saltwater intrusion. That's when we pump all the groundwater out and the salt water comes in to fill it up. Plants don't grow in salt water. The Mekong Valley, Vietnam, the sign says you want to buy some land. I'll sell you some swampland in Florida too. Millions of people forced to move. That leads to this notion of the cost of carbon. So hopefully by now you can sort of connect those dots. You understand how these are all fitting together, how they're all caused by the same thing, and it is the #1 threat to global economy and to human health. So when we look at subsidies, how much money we hand out to, good technologies and bad technologies, we're kind of losing that battle in trillions of dollars. In subsidies, 36 times more money is going to the fossil fuel industry than renewables. U.S. examples, disturbing. So there was an island in the Pacific that was a forested nation, and the people worshipped trees, and it was known as Easter Island. Now there are no trees. The people literally worshipped the trees to death, and they ceased to exist. So now we start getting to some good news. So we have the solutions at hand. When we look at one technology, wind, and when we started fully installing these wind turbines around the world, industrial wind turbines are referred to, we thought that wouldn't it be great if we can get 30 gigawatts of power in a decade. In reality, since this is the Climate Reality Project, we looked at it, we overachieved by 20 times more than what we thought we could possibly do in the best case scenario. That is what we call a parabolic growth curve. The increase of these technologies being implemented in the US and globally, and at the same time, this is a cost down curve for the same technology. As we put in more, it gets cheaper, and as it gets cheaper, we put in more. And it's gotten to such a point in Texas that they're giving away free electricity at night because the wind still blows and the demand drops. So it's like, hey, you might as well burn it. We don't need it. most competitive sources. I'm just going to quickly populate this. Looking around the world, I go, well, wow, wind is pretty widely distributed. It's not just in the Middle East where oil is. 2/3 of the world's population can benefit from this. Take a look at it. If we measure how much wind is blowing around our planet at any given moment, we can derive 40 times more energy than we use in everything on our planet from wind alone. 40 times. Well, there's another little technology in town called solar. You've seen it appearing on buildings near you here on campus. That's what I do. We had a wild guess. We thought we could hit a gigawatt. Reality, we overachieved by 17 times. Last year, well, we were only 109 times more than what we thought was humanly possible. Global photovoltaic installations, solar electric, that is a serious parabolic growth curve. If you're into the stocks, buy low, sell high, right? American capacity, similar around the world. Again, cost down curves for the technology we use to create that. Nevada, 2 cents, we're paying about 15 cents a kilowatt here. Minnesota, prices are dropping by 1/3. When's the last time your hydro bill dropped from nuclear? 1 in 5 houses in, where's this, Australia? Solar panels. Deutsche Bank made this observation, and they have a term here called grid parity. And when we think of parity, we go, that's when we can make energy at the same cost, bad energy and good energy. And when we look in 2009, a decade ago, when we spent money on new energy, it was kind of half and half, a little bit more on the dirty fuels. Step forward 4 years, wow, there's a major separation. Come up to near present time, and you get a picture of what's going on around the world and why solar panels and solar walls and crazy things are happening to your campus. Let's look to your future. This is your planet, right? 2020. You're all graduated. By the way, 90% of the grads from Fanshawe's 200 programs get a job within 6 months. Highest in the nation. 2030, when it's your planet, I think we got it under control. Some nations are divesting entirely from oil and gas. When we look at how much energy costs around the planet, the reason they're divesting is the cheapest source of energy is renewable now. I've been doing this for 40 years, and for 39 years, they've said, shut up, Davis, it's too expensive. We know it's great, but we can't afford it. Now I say, what's your excuse? We'll look at a few of these technology cost down curves, residential, commercial, battery storage. 82% less, yeah. That drives the market further. LED, 95% less. New capacity being built last year in China, 53% renewables. What about India? Well, better, right? And we thought this was going to be where all the coal power plants were being built. Those have all been canceled. European new power generation is way ahead of us, and the reason is they had a 20-year head start. We're just as smart. US, I'm not going to make any intelligence comments there, but we look to Donnie's friends, the coal miners, and the Kentucky Coal Mine Museum, and I worry about them, and their source of power is their roof. And by the way, it's the right color. It's white. Somebody on Earth gets it. So when we're engineers, we have a technical term we call swag, and we make a guess. It stands for scientific wild ass guess. So me and Tal, we made guesses and we were way wrong. So it's important to understand why we're wrong, and we're going to look at one technology that each of you has in your pocket right now, a cell phone. AT&T, back when I was a university student, said, hey, I bet we could sell almost 1 million of these things. Well, did they? Yeah, they sold a few more, right? In fact, 120 times more than they thought they would sell in their wildest dreams. Now, there are more cell phone connections on Earth than there are people on Earth. We need to understand why we got it so wrong. I think about that. Al thinks about that. By the way, that's what Al looked like in 1980, and that's what a cell phone used to look like too. So the reason that we were wrong is the costs have come down. You've seen those cost down curves on all these slides. We've got way better. Back then, a phone call was a phone call. All I could do is talk on that damn thing. Now I use my phone for everything I use a computer for. And the real shocker is we thought we were going to sell them to the built-out Western world. Well, it was the developing world that snapped up the technology because they didn't need to have wired phones. Well, how do we get our electricity into this room? Wires. Well, there are no wires in Africa. How are they going to get electricity when their grid looks like this? Simple. The grid in the future is no grid at all. Our buildings become our power plant, so that means there's no power plant in the future. No power plant, no grid. Our buildings generate the energy, kind of like our buildings here on campus do now. Some of them started. Pay-as-you-go solar, we arrange microfinancing, so for a few pennies a day, people that used to burn kerosene for their children to study homework, the children are dying of lung cancer, can now, there's a wire that comes down into their house, there's a USB port for their cell phone, and an LED light bulb so their children don't get lung cancer. Same thing here in Bangladesh. Children in Africa learning on computers powered by solar energy. These solar installations were actually put over an old open pit mine filled with toxic water. Had no value to anybody, so they turned it into a solar farm. Largest one on Earth right there. Another one under construction in China. This is called concentrated solar power. CSP is slightly different than photovoltaics. Not enough time to talk about it. Excuse me, India. California is 73% renewable. The Vatican is the first nation on earth to commit to 100% renewable. Al tells me they have two advantages. It's a very small country, and apparently he thinks God is on their side. So they might hit there. Chile, very dry, arid part of the world. I wonder what they're doing down there. Well, 13, 16, 2018, now. This is the good news. These are jobs that never existed, and your future holds a full employment economy. Why? Because we have a screwed up planet we have to fix. They're shutting their coal-fired plants. They can't afford them anymore. What about India? We saw a few installations there. Well, in process now. Way more than Canada. 25% cost reduction over dirty sources. Renewable energy capacity going forward is the way to go, the only way to go. You have to be courageous. You'd have to be insane to buy a coal-fired plant today. It makes no economic sense. And when we talked about 40 times more energy from wind, when we look at solar energy, the multiplier is 10,000 to 1. That means 1 hour of sunlight is enough to power, that portion of the earth for a year. 10,000 times more energy than we use in all forms is being rained down upon us 24 hours a day, 7 days a week. Battery storage is on the uptick. What about your future? Looks pretty good. Cost down curve. That's what we like to see. Solar and batteries, now we don't need the sun to shine to get the electricity. We're on it. Richmond's actually tearing down, we're building gas-fired plants here. In California, they're tearing them down because it's stupid. Electric cars. Old technology, new technology. Guess what? We have our price parity in 2023. So you don't have to wait for the government to give you a subsidy. In a couple of years, the cost of an electric car is going to be the same as the cost of an internal combustion engine. What are you going to buy? Silly question, right? I like our India's there, right? Other countries, well, we're here, 2040. Auto manufacturers, They get it. GM even gets it. Volvo's already there this year. All hybrid or electric. That's all you can buy from Volvo. Transit? Yeah. We're going to urbanize the planet in the next 100 years. We're going to have bigger cities, more transit, and taller buildings. Zero emission buses have already been committed in those cities. I know I'm running out of time, so I'll be very fast here. Jobs, renewable energy jobs, 11 million today that didn't exist 2 decades ago. Number one field for growth of new employment, wind turbine service technician. 5 times faster growth in jobs in renewable energy than other sectors. This is what I'm doing to the campus. I'm making it more efficient. The next candidate other than Castro Court is the K building. We're going to make it net zero. Multi-billion-dollar market. And by the way, I call that knowledge transfer, and I'm here to teach students how to do that. I already know how to do it. LEDs, down curve, and that leads us to the COP talks in Paris at the end of 2015, where the entire planet agreed that we're going to do something about it. Every nation on Earth agreed to that. They signed on the dotted line. And by the way, the good news is the one and only time we ever did that in the past was when we blew a hole in the ozone layer with Freon. So the United Nations got together and they banned the manufacture of that chemical from everywhere on Earth. And now the ozone layer is healing itself. So we know if we act as a planetary species that we can fix it. It doesn't really matter what happens down there. And in fact, all of these drivers, it doesn't really matter who's sitting in the White House either, because industry is all over that. Coal plants proposed, existing plants retired, new ones that weren't ever built, done. Close the chapter on that, right? Coal shutdowns, this beautiful Obama, right? Look how many shutdowns happened in Trump's first 2 years. Coal consumption, down curve, I love it. What's this mean? Oh, same price, parity. That means I can make electricity the right way and not destroy the planet for the same or less cost. So shutting down coal-fired plants like we did here in Ontario. Number of financial institutions are basically pulling out of that market of giving funding to these. Cities that have committed to go 100%, cities that are already there. Companies that have committed to go 100%. I'd like to see Fanta's logo up there. Working on it. Our neighbors, they've kind of drank the Kool-Aid, they get it. Clean energy power purchase agreements on the uptick. China and India are both on track for the Paris Accord. And so reorganize. This is a grassroots initiative. This little grassroots march was 1 million people in Central Park. So there is strength in numbers. And that brings us back to the beginning, the very first picture of our home, taken from somewhere other than our home. And within 18 months of this photograph being snapped, we had our first Earth Day. So that was a groundswell. This is the most reproduced picture on Earth, and it's of Earth, and it's called the blue marble. I call it a selfie, right? So the great late Wallace Stevens once said that after the final no, there comes a yes, and on that yes, the future of your world depends. Thank you.